Thank you so much for coming back today at our channel, The Physics Mindset, the channel which is going to deliver you electrical engineering, solar engineering, and electronics. Now today, we are going to look at the history of electricity. What is the history of electricity? Electricity is a professional subject. Okay? It's like electronics also is professional. Solar is professional. Three of them are professional subjects. Students, engineers, technicians, you're welcome on this channel. Now today we are going to see how electricity came in. Who started the electricity? How do we define electricity? Before we start doing our wiring in the houses, our installations, circuit breakers, switches, sockets, how did electricity come in? What is the history of electricity? And what is electricity itself? Okay, we are going to see it in this video today, so that the more we go far, we know the fundamentals, the ground floor where electricity came from, the founders. Okay, now what if they ask us the question, what is electricity? If it is you and you hear such a question, what is electricity? A lot of us, we know electricity. We know when our lights are giving us light, our bulbs are giving us light, our TVs are working, our fans are on, we are getting fresh air, our cars start with a battery, with a key. But where do they get this power source of electricity? And what is this electricity? Okay, we want to dig inside the electricity. Now, we start with the definition. Technically, I'll give you a definition of electricity, that electricity or should I give you as a homework that you can, so that you can give me in a comment section the definition of electricity? But some will say, why? We have no time. Let me give you. It is the flow of electrons through the flow of electrons through a conducting material. A conducting material like a wire or a copper wire. Let's say a copper wire. Okay, I think here you can pick something. You can pick something from the definition. The flow of electrons, or the movement of electrons through a conducting material like a copper wire. Okay, something conducting. You know, there is conductors and insulators, though we shall go next to those topics. But a conducting material, something which allows electrons to flow or to move through it. Now, that process of electrons moving through a conducting material is the electricity. Since we have electrons moving, we shall have electricity in all ways. Okay? Now, guess this electricity. Try to think like water. Water moves through the pipe from one place to another. That is water, right? Let's say this is the pipe. Okay, now this is our water. Water moves through this pipe from this place A to place B. Okay, it moves from through the pipe, water. The same science is, this is our electricity. Electrons. Electrons. They move through, let's say this is our copper wire. Point A, point B. Now, once you connect your electrons, your power, electricity, to move it from point A to point B, it will need some conducting material, like a copper wire, moving from one place to another, meaning electrons or electricity, to move from one place to another, we shall need a wire or a conductor, okay, to move it from one place to another, either copper, either aluminium, okay, it depends which cable, which conducting material you're using, okay. Now, since you have seen the definition of an electricity, take it to be, it is the flow of electrons. Electrons are negative charge. Electrons are negative charged. Okay? Now, once we have electrons inside a copper wire, once it moves, meaning what pushes electron to move? What pushes electron to move is volt. Volt is the pressure which moves current. Okay? That's the science, but we shall go much deep when we reach on, when we are studying the voltage. Okay? Now, just like, let's imagine we have a battery. We have a battery. One. We have a copper wire or a conducting wire. Okay. Let's say we have also a bulb and a bulb. Let's connect these things and we see what is electricity. What do they mean by the flow of electrons through a conducting material like a copper wire? Let's design something. We design a battery. This is a battery. Positive, negative. This is our bulb. This bulb here. This is a symbol for bulb. Right, we shall go and see some electrical symbols which you will use when you're doing your drawings. Okay? And these are one of the symbols. This is the symbol for bulb. Now, positive, we shall connect it to the positive side of the bulb. Let's say this bulb also is a DC, okay, battery 12 volts, DC, and a negative goes to a negative side, and this is what we call an electric circuit. This is an electric circuit. The name electric circuit means you have connected, you have the source which is the battery, the cable, the wire, and the bulb. It is a complete electric circuit whereby this bulb will give light, will light up. The bulb will light up. We have the copper, the wires, and the battery. Okay, and this is when here the battery stores chemical energy, and this chemical energy in the cable wires, it is converted into electrical in the wires. Okay, in the wires it is turned into from chemical to electrical energy, from chemical energy to electrical energy, and once it reaches the bulb, the bulb starts lighting. And it converts the electrical energy into light energy. Hope you're getting me well. Let me hope I'm not rushing. I don't want to rush because in electrical, we don't rush and we don't forge and we don't guess. We do what we know. You can't wire a house without knowing either positive or negative, either live or neutral, either earth or. Now, this is an electric circuit diagram. Chemical energy converted into electrical energy, and electrical energy is converted into light energy. That's when we are seeing lights in our houses. That is light energy. But someone can ask, where do this, we see power all over the country. What are the sources of electricity? Someone can ask that question from nowhere, because we have different sources of electricity, right? Now, what are the sources of electricity? Before we jump in the history, today we are seeing the history of electricity, okay? Now, one of the sources, let me give you just, I'm giving you brief explanations so that you can know where we are going. I'm going to give you some brief history, the historical fundamentals of electricity. Who started electricity, how it came up, and how do they find this system. But let me give you some of the sources of electricity. Let me write it up there. Sorry. Now this is a small experiment which I was showing you. Okay, let me say sources of electricity before we jump into the history, the conch history of electricity, which you are going to see. Now, what are the sources of electricity? I know some of you know, you just see your light in the house, but where does that electricity come from? One of the sources is hydroelectricity power. Hydroelectric power. This hydroelectric power, this type of power is from the flow of water. It's got from the flow of water. Flow of water. That is where you will find the dams. Okay? Yeah, that is the dam. On the dam, on the flow of water, when the water falls, the water drive the generator. That's why we are going to see. And who brought the generator to be in existence? That is the history where we are going. Just a minute. The flow of water, hydroelectricity power, it is got from the flow of water. Number two, this is one of the source of power. A lot of countries use this in African countries. Okay? Now, number two, we can have, what else? I know there is some source of power which the last videos we have finished. Solar power. Solar power, it is also a source of power which is got from sun rays. Sun rays. Once you put your solar panel on the roof, you get the solar power. It is also a source of power, and you can light your gadgets in the house. The third source of power, we can have wind power. Wind power, I mean, here we use the hair, the moving hair. We got it from the moving air. That is when we are using the wind turbine. I think you have seen something like this. The fans, mostly there are like 3 of them. Yeah. Now when the wind comes, these fans start rotating. This is the ground, this is the pole, this is the fan. The cables pass through this pole inside. Now when the fan starts moving, mostly this type of wind power is found in European countries, America, Canada. Okay. When the fan turns, we see it generates electricity. It has a motor inside. And that is the history where we're going a moment. And we shall see one of each of these ones in brief so that you understand well. Hydroelectric power, solar power. I know solar power, we have finished it. Now, wind power, that is when it uses the wind turbine. These are turbines. They are drove by the wind. But hydroelectric power, hydro means water. The turbines are drove by water to produce electricity. Now the fourth one is thermal power. Thermal power is got still mostly in not in African countries. This not more small countries can use this because of the materials. Now it is found mostly in European countries, America, that side of Canada. Okay, this is the power, the source of power whereby they burn the fuels to run the turbine. Okay, that fuel which is burnt, there is a steam which comes out, and that steam runs the turbine. This is good from the burnt of the fuel and some natural gases. Yes, natural gases. And these are some of the types of electricity we shall talk about. Hydroelectricity power, solar power, wind power, and thermal power. So now, I know my people want to hear about the history of electricity. Okay, let us jump in the history of electricity. History of electricity. Everyone, you should know where do that electricity came from? When? Where? Who brought it? Okay? And how did he know that it is electricity? Okay? How did she know? He or she? We don't know, but we need to know today. Now, without any wasting of time, let's jump in to the history of electricity. I was giving you some definitions, some basic words, and the sources of the sources of electricity. Okay? Though we shall study them into depth so that we understand everything about the sources of electricity. Okay? Now, before we do anything, let's try to take back our mind. Years back, in 2000 years back, years ago, okay, there came a man called thales of miletus. Thales of miletus, 2000 years ago, he was a Greek philosopher, a scientist, and a mathematician who was eager to prove the world that there is what we call static electricity. You know, we started with electricity, static electricity, before we got the DC or the alternative current. The direct current, which is the DC, or the AC current, which is the alternative current, okay? But with the first experiment was made by this man, Thales of miletus. How? This man, in his great thinking, in his philosophy, his scientific experiments, the concepts, he discovered that when you rub amber with with fur, when you rub amber with fur, there will be a force of attraction. What do I mean? What I mean here, a fur, let me give you, I know some people may ask, what is a amber? Amber, you see, like, let me give you an example of, you see pine trees. Pine trees have that liquid. When you cut a tree, there is some liquid substance which comes out from the tree. Okay, some people use it like gum. It's more of a gum. Okay, now that is the material of amber. It is brownish, reddish in color. Okay, now once you collect that amber, and when it gets dry, it hardens, it solidifies. Okay, now when you rub it with fur, for example, you can rub it in our hair like this. So after rubbing that amber with fur, there will be a force of attraction. A force of attraction on amber. This is, let's say this is our amber from the tree. Now, when it is dry, it solidifies. Now, when you rub it with fur or on a hairy body, or in our head like this, when you rub it like this, now let's try to see. Let me see. This is the amber. Try this to be the amber, even though we don't have it here, but we are doing the experiment. When you rub the amber with our head, in our head, this amber will have some forces here. Force of attraction. Positive, negative, positive, negative. And this force of attraction will be able to attract light objects. Okay, light objects like dust or feathers. Okay, this is the experiment. He used the experiment to attract dust or feathers. These are light objects. When you rub amber with fur, this guy, thales of miletus, his experiment, he wanted to experiment to find out that we can have charges once we rub the amber with fur. And his experiment was proved. He proved it, and it was the first recorded observation of static electricity. This is the foundation. I'm giving the history of electricity. The first observation of static electricity. You know, electricity, we have types of electricity. We have static electricity. We have direct electricity. That is the DC, which is, no, DC, direct current. Then we have alternating current or electricity, which is AC. Now, this is a DC, a direct current, alternative current, but we started with a static electricity. That was the beginning of the electricity, okay, found by thales of miletus. And he experienced that once you rub amber and fur, you will have a force of attraction, and amber will attract dust, feathers, meaning there is electrical charge on amber. And this was the first recorded, observed experiment to show that static electricity is present. That was the number one experiment. Okay? Now, scientists didn't stop on this experiment alone. They went on and researched, did experiment, drive some they calculated some concepts, okay, to come out with a lot of concepts. Check this. Still in 18s. These are 2000s. Now in 18s, there came scientists. Scientists. Check. Who was that scientist who came again? He was Benjamin Franklin. Benjamin Franklin was a prominent scientist, still a mathematician, a philosopher. Okay? He wanted also to prove, since we have found static electricity by rubbing amber with fur, experiments started going on. People started developing. The scientists started thinking. They come together. They bring solutions. They problem solving. Someone calculates something. They call a committee, and that if you have an idea, you tell the committee. Now Benjamin Franklin was doing also some experiment with other scientists. We are on the history of electricity. We have found static electricity. Now, Benjamin also wanted to prove the world that electricity is the same as lightning. Now check. He wanted to prove that electricity is the same. All properties of electricity are the same, like lightning. His experiment, he wanted to experiment that also lightning is electricity. The same way electricity is like lightning. Also lightning is electricity. Until today, we believe that lightning is electrical, it has high voltages. That's why check where the thunder has destroyed. That is high voltage. If it finds a human, it can burn you. Okay? Meaning it is having the properties of electricity. Okay? Now, this Benjamin Franklin, how did he try to solve or to show his experiment to the world? This is how. Benjamin Franklin, a scientist, prominent mathematician, proved in developing scientific concepts. Okay? Check this experiment. Benjamin got a key like this. Benjamin got a key like this. Okay? This is a key. He got a string. He made a kite. Let's say this is a kite. He got a string. This is a kite, right? He got a string. He tied on a key. This is our key. Okay? And he got a string which he pulled. This is our Benjamin. That is the hand. This is the Benjamin. Okay? Now, Benjamin Franklin, to prove his experiment, this key, the key you're seeing here, this is a key, metallic. He tied it on a kite. It was during storm. He wanted to prove that lightning is also electricity. You know, we are finding where we get this electricity, the fundamentals of electricity, the history of electricity. Now, during the storm, it was extremely dangerous, which is okay. It is okay that it's dangerous, but Benjamin Franklin, and other scientists decided to experiment this. Okay? They started running in a storm full of thunderstorm. That is risking your life. The string was very long enough and the kite was a bit far. I think you know that put the image, the film, check this, like imagine, say something in your head what I'm talking about. It is during a storm, heavy storm, extremely dangerous to walk in heavy storm because there is also thunderstorms, okay? Thunder, lightning in that storm. Benjamin decided to experiment with a key tied on a kite. Now, what happened? When the storm, under thunderstorm, the thunders were lightning, okay? And there came on the key some sparks. He experienced some sparks on the key. And in his hand, he experienced some, what we call the ambient, we call it the ambient electric charge. Wow. This was a great scientist. He experienced what we call an ambient electric charge in his hand when the key had some sparks on it, meaning the lightning came and passed through the key, or the key picked some charges in the thunderstorm, and these charges caused some sparks on the key, and on these sparks he felt some ambient electric charge in his hand on the string. You see that experiment? This guy, Benjamin Franklin, after realizing that a key has picked some charges from the storm or from the lightning, he proved his theory that lightning is electricity. He proved it that lightning is electricity. It was in 80s when Benjamin Franklin did this experiment to prove that lightning is electricity. That's why don't play around when the lightning is there during thunderstorms. Okay? This is electrical. Lightning is electrical. Now we have found another electricity. The experiment done by Benjamin Franklin. Now, after Benjamin Franklin discovering that lightning is electrical, now came, after some years, scientists started doing again their research, their experiments in their laboratory, doing some calculation, physics, mathematics, combining the concepts, checking where they can mix the components, how to generate electricity. A lot of years came by years. Okay, here comes another scientist. Sorry, let me rub off this. Here comes another scientist who was called. This scientist discovered that when you combine some plates, when you combine some plates together, you form a battery. When you combine a positive plate and a negative plate, you form a battery. And this scientist was called who? He was called Alessandro. Alessandro Volta. Alessandro Volta was another scientist. After some years, after Benjamin Franklin has experimented this with the key on the kite to show that a lightning is electrical. So from today, don't play with the lightning. It will shock you, or it will burn you on two, or it will kill you because it is electrical. So now, after some years, Alessandro Volta came up also with his concepts through calculating, through doing the mathematical equations, the concepts. He came up, he was the first person to discover what? To discover the first electric battery. The first electric battery. Or a battery. Let me call it a battery. Alessandro Volta. And that's why, for his name Volta, not to forget it, the batteries are measured in volts. Hope everyone, we are together here. Batteries, let us say, a battery of 12 volts. You know where this volt came from? His name, Alessandro Volta, the first scientist to discover the first electric battery in the world. Light was there, and people were using candles, fuel, to light their homes. True, light was there. But scientists wanted to add, to improve on the light. Okay? Before when Alessandro Volta discovered the first battery, okay? The pile, and this battery was called the voltaic pile. The battery was positive, negative, positive, negative, positive, negative, positive, negative. Now, this is positive, negative, positive, negative, positive, negative. Okay? Now, this pile, the combination of these plates, positive and negative, was called the voltaic pile. They pile up these plates, positive plates and negative plates. Then he combined with some liquids inside. And this is the first battery, which was having positive and negative terminal. It was invented by Alessandro Volta. Let me give you something which you didn't know. Do you know that electricity, no one invented electricity. Listen very well. No one invented electricity. No one invented electricity. Now, the human beings, what they did, they studied how it works. Because electricity was already in nature. Electricity was already there. But people didn't know how to bring it up into existence. But it was already in nature. No one invented, but they just, there is some two words. There is inventing. Let me rub off this. Okay, with this. Now, There is some word which I want to show you. There is inventing, Benjamin Franklin, let me rub it. There is inventing and discover. These are two different things when they come in scientific, those scientists. Or someone discovered, or someone invented. There are two things, discovering and inventing. Now, electricity was discovered, meaning it was already in existing in nature. It was already there, made by God, I think. That's why they discovered, like looking for something and you find it. But inventing, you start the concept from zero. You start building something, like how Alessandro Volta invented the first battery, the first electric battery. But he didn't discover. If we say Alessandro Volta discovered, it means the battery was already there, but no one was seeing it. And once Volta saw it, it means he was the first to see it, to discover, not to invent. But since here that he invented the battery, it means he was the one who started from the script, designing, calculating, mixing the chemical reactions, burning the components, the plates. Okay? He invented the battery. He didn't discover, but electricity was already in nature, and no one invented electricity. Hope we are together. People only discovered electricity, meaning electricity was there. Okay, now let us go. Once the Volta, Alessandro Volta discovered the battery. This battery is measured in DC. You know, batteries are in DC, okay? Direct current, which moves in continuous one direction. But there come another scientist. Wow. This scientist who saw that since Volta, still in 18th centuries, since Volta, Alessandro Volta has discovered the first battery, and yet we want to transfer, we want now to use this battery to light our bulb. Now here comes another scientist, a physician and a mathematician by the names Thomas Edison. Thomas Edison did a great work in the revolution of the world in lighting. Thomas Edison came up with the bulb. Wow, these are now. Let me write here, Thomas Edison, a scientist, a prominent physicist, and a physician. He said he tried experiments since people were burning fuel to light, to candles, okay? How can we use this battery to have light? Thomas Edison did a lot of hundreds of thousands experiments, but he was failing. But he never gave up. He continued doing the concepts, trying the concepts, calculating, adding this, connecting this, but it fails. It connects, it fails. It connects, it blows. Since he rated something good, and he came up with the first electric bulb. Oh God. This one was the first he invented, okay? This one they invented, they didn't discover, but they invented the first electric bulb. Alessandro Volta, the first battery. That is, you know, electricity started with now we are coming in the battery. DC was the first electricity to be found. As I told you, we have static, we have DC, that's direct current, and we have AC, that is alternative current. Now, since we are still in DC, those centuries in 80s, Thomas Edison invented the electric bulb. People started using electricity using DC, the battery, which Alessandro Volta invented. He didn't discover, he invented. But I told you, only electricity was discovered. No one invented electricity. It was in existence, or it was in nature. But it was there. But people, what they did, they just learned how to use electricity. Where are we? Since Edison invented the electric bulb, people started using the bulbs, coming up with the bulbs. Now, people wanted also to use this DC power from far. Okay? They wanted to use DC power from far. So that now the scientists started thinking of how can we transfer our DC power, direct current, from one place to another place, from eastern part of the country to northern part of the country to southern part of the country to any place. How? It was much expensive to transfer. Let's say these are the batteries. Now you want to transfer this power from eastern side of the country to western side of the country. This power is very little. You can't transfer it using these electrical poles. Okay? It is going to reach somewhere when it is no longer, when it is weak to power anything. Meaning, you need to add a lot of batteries to make a lot of huge quantity of electricity, high voltage, so that you can transport it or transmit it to another area. Here comes another scientist. Now they were sitting in a committee trying to look for solution how they can transmit this DC power to different areas. Now there come a scientist, also a mathematician, a non-concept design. He was by names Nikolas Tesla. Now, since we are looking to transport DC, Nikolas Tesla came up with a concept. Let me write here. Nikolas Tesla. Now, this Nikolas Tesla also was a scientist, a physicist. You know what he did? He is the founder. Oh, the inventor. He invented. All these people invented. This one invented. Edison invented. Volta invented. Nikolas Tesla brought an idea to change this DC into AC. He was working on the principles of electromagnetic induction. This Nikolas Tesla brought an idea in his concepts. He brought an idea of electromagnetic induction. Electromagnetic induction, what I mean, listen the word. Electro, that is electricity. Magnetic, that is magnet. Induction. Induction is a coil. You get your copper wire, you round it or wound it on a magnet. That is your magnetic induction. Now, once you add electro, meaning we are now dealing with electro. He brought an idea with this principle of electromagnetic induction. And this is when the beginning of the generators. This principle, Electromagnetic induction brought the beginning of generators, whereby he started designing the motors. Generators have motors inside. You see how electricity is coming? Now, these motors are powered by a DC. Some are worked, these generators, once you start, they are powered by a DC, but they can produce AC. And this principle of electromagnetic induction in the motors, in the generators, in a generator there is a motor. That's why in a dams, our dam, hydroelectric power, we use generators to produce power. Okay? A generator converts the mechanical energy in the motor into electrical energy. That is the definition of a generator. And this principle, this generator, it works on the principle of electromagnetic induction. Let me hope we are together. We are on the history of electricity. And since Nikolas Tesla brought this idea of electromagnetic induction and the starting of generating the generators, the motors, that a motor can convert mechanical or electro or magnetic fields into electrical fields. Now, let me give you a slight experiment. This is your magnet, North Pole, South Pole. Now, I'm telling you electromagnetic induction. You get your wire, your copper wire, you wound it on the permanent magnet like this, like this, like this, like this. Okay, this is our permanent magnet. This is a magnet. This is our this is a copper wire. Okay, I'm just bringing up some small experiment. And if you have two of this kind, you know, when you want to create electricity, it's very simple. This is the principle which Nikolas Tesla brought, that when you get a permanent magnet and you wound a wire around it, and you get another permanent magnet, you wound a wire around it, these magnets, remember, they have what we call electromagnetic fields, not electromagnetic these are electromagnetic induction. Okay, now a magnet has fields around it, positive fields and negative fields, which attract or repel. Okay, once a positive, this is positive, this is negative, positive, negative, these are two magnets. Once a positive and positive bring them together, what happens? Repulsion will act, the repulsion act or repulsion force will be there. Okay, because there is a force. And once you put another, a positive pole and a negative pole, or south and north pole, there will be an attraction. It's like a man and man, repulsion. A man and woman, attraction. Just a simple illustration. Now, when these magnets, you have wounded around the cable around them, and you bring them near together, and you start, if you start doing like this in a high speed, that is the introduction of the dam. The dam, that's where, now, this speed, remember, a magnet has fields. Now you're disturbing the fields. Also, this one has fields around it. Fields, I mean, this is the magnet. It has fields like this, in north, south. Now, these are the fields. Okay? These are the fields. These are positive. These are pushing. This one bring inside. Okay? Now you bring another magnet beside this one. This is north, this is south. Also this one has, also this one has. You see, now they are going to interfere in each other. The moment now you do them like this, electricity, if you put a cable inside there, you will have some electricity in or live. You will have a live. If there are two outlets, two cables like how I've told you here, you will have one will be live, another one will be neutral. You select one, but all can be live. Since you have not connected any load, all become live. And this is the generation of electricity, the history of electricity. And this is how a dam works. We shall look at the dams when we reach at explaining on the dams. And this man Tesla did a very great work up to today. Why we are seeing electricity, why we have dams, why we have the wind turbines, because of he brought the beginning of the motors, and he wanted to transfer this DC into longer distances, transmission to longer distances, meaning DC, it is expensive. You first add a lot of batteries so that you can move in few distance. But on AC, once you use electromagnetic induction, that is a generator, power, AC power has high efficiency that you can transmit it to higher or to longer areas, long distance areas, okay? That is using AC. And this is now, Tesla he invented what we call alternative current. Alessandro Volta invented what we call DC current. But Tesla invented AC, which is the alternative current. And this is a great man. Tesla is so great man, but the founders are there. Edison also did the bulb. That's why we are lighting. Nikolas Tesla, that's why by his name, one of the scientists who is there today, who is called Elon Musk, he decided to use his name, Tesla, because his cars are using electricity. He is using electric car. The first person to start making electric automobiles, okay? Electric cars. And he used the name Tesla. That's why you hear cars called Tesla cars, because of this man, Tesla, Nikolas Tesla. Just to remember his name. Now he named the name to his company making cars, Tesla cars. And that is how this electricity came into. Now we have AC. Remember we started with static electricity. Then we went on and found that the first battery made by Alessandro Volta, which was called the voltaic pile, the first electric battery. Now in the confusion of transmitting DC to long distance, Nikolas Tesla came up with an AC through inventing the motor and the generators, whereby a generator produce an AC output. And that's why we are lighting today. These guys did a lot of work in the revolution of the world, in the department of electrical, and we are still living in their thinking, what they thought those years in 80s. Okay? And this is how the history of electricity started. Hope you have enjoyed the video. If you have enjoyed whichever country you are, please, you can type your country and I will know that you are watching and you enjoyed. Thank you for watching for today. Hope see you in the next video, which we are going to study about the types of electricity. Types of electricity, you need to know. I need to explain to you the types of electricity, whereby we have the static electricity, which was formed by thales of miletus. Then we shall study also the DC electricity, how it came up which was found by Alessandro Volta, DC. Then we shall study also the AC electricity, alternative current, which was found by Nikolas Tesla. And this name Tesla, these are the cars you're driving today, the Tesla cars, which are using electricity, electric cars. The founder of AC current. Thank you. See you in the next video. Don't give up. Subscribe, like, and share with your friends, family, so that they can know also, they can know with us. See you in the next video.